coming. My name is Sébastien Taylor, and I work with Ozone Technologies. Uh, Ozone develops machine learning tools for embedded systems. So the tools help you design, train, and deploy to embedded devices deep learning solutions. And on the embedded device, allow you to run the inference on the low power devices. Today, we're going to talk on not just about running on the target embedded device, or edge embedded device, but also leveraging the cloud to add additional functionality to the device that maybe it couldn't have done before, as well as allowing smaller models to be deployed at the edge. Well, this is a pretty accurate depiction on what machine learning is. It's a comic with XKCD, so you've got some data, you want to get some sort of answer, you kind of shuffle it until you get the right answer. When you don't, shuffle it some more until you do. And then to do this with the cloud, we basically end up with two piles of data that we need to shuffle to get the right answer, and the difficulties involved. So in terms of the actual architecture, so cloud is, you're able to run multiple models there, much larger models, whereas on the edge, you're limited by your power budget. In the cloud, you're effectively just limited by your actual budget. Optionally, you could have edge server, so an embedded class server device, so maybe you can aggregate all your edge devices and collect through a central point. And then the actual edge nodes, which are resource limited, low power devices. And when speaking of edge nodes, what we're interested in is quite low power devices. So either MCU class devices, under $3, under 150 milliwatts, maybe with a few hundred kilobytes of RAM, or what we call a large device, under 2.5 watts, a few hundred megs of RAM, maybe running Linux.